Hi everyone, welcome back. It's Monday and we're looking at a revision lesson. So this will be something that you hopefully can already do, but just to quickly revise it because you're going to need to be able to do it in the task. So this week is focused in on primes. We need to get some language sorted. So today is multiples and we're going to be looking at those. There's also going to be some factors. You need to know what the difference is between those two things, factors and multiples. You also need to know the definition of an integer. That's a whole number, including negative numbers. You also need to know about a prime. So what I suggest you do, if you don't already know about those things, is have a little Google, go to Maths is Fun, find your definition, because you're going to need to do some word definitions for the first part of your quiz. Now, we're going to look at multiples for a second. I know that this is going to be quite straightforward, but multiples are all the numbers in the times table. Sorry about the weird font, I can't fix it. So for example, the multiples of 7 would be 7, 14, 21, 28, 35. Please make sure that you include, when you're thinking about multiples, think about including the number itself. So for example, 7 is a multiple of 7. And obviously there are infinite numbers. You can keep going here until you, I don't know, get up to way more than 700 billion and you'd still be going. So there are infinite numbers of multiples for 7. So very quickly, can you just write down the first 5 multiples of 6 for me? Pause the video, have a go. You might even be able to do it while I'm talking, but the first 5 multiples of 6. Okay, so hopefully you've written down 6, 12, 18, 24, and 30. And how about the first 5 multiples of 8? Okay, so hopefully 8, 16, 24, 32, and 40. Now we're going to skip this one because that's a bit straightforward. Now, the other thing that we can do is we can look at Venn diagrams. We have multiples of 5 on one of our sets. We have multiples of 10 in the other set. And of course, as I'm sure you're aware, in that crossover between, we can have the things that are both multiples of 5 and multiples of 10. And you might be thinking already, there's something going on here. Think about it. What's going to go into each set? And obviously 5 and 10, 15, 20, you'll notice that nothing is just in the multiples of 10 part of our Venn diagram. Okay, so what I want you to do is you can quickly draw this. You can skip it if you want to, but quickly draw the multiples of 2, the multiples of 4, and fill it in on your Venn diagram. Okay, and hopefully you've got something. Oh, it's gone. But hopefully you'll find that all the multiples of 4 go into our intersection and nothing goes onto the right-hand side. Okay, so, oh, there we go. Lovely. Now, the next part of your quiz is going to be about divisibility rules. There are rules for everything, although the 7s in particular are one that people particularly dislike. This is exactly the same sheet that's going to end up in your quiz, so don't worry, you don't have to copy it down from this video. The ones to focus on, I'm fairly confident that you know divisibility rules for 2s, obviously if it's even. For 4s, hopefully. And for 5s and 10s, I don't think there will be a problem there. The ones to look at here are 7s. And for 7s, if you think of any number, so think of a 3-digit number, for example. Let's try and write one down for you. So if I come up with 846, for example, if I want to find out if it's a number which can be divided by 7, I take the last digit and I double it, so I'll make 12 here. I do 84, which is the bit that's left over, take away 12, and that will give me 72, 62, give me 72. And if 72 is in the 7 times table, then I know it's divisible by 7. Well, 72 is not, and therefore 846 is not divisible by 7. So that's the 7s. The 11s, if you subtract the last digit from the number forming the remaining digits, if the new number is divisible by 11, the original is divisible by 11. Now, there's another rule for this one as well, which is that if you, oops, sorry, gone too far backwards. If you write the number out and it's a 3-digit number, for example, if you have 343, I can tell you that this one is not divisible by 11. And that's because if you take these 2 digits, the total of these 2 digits should be the same as the number on the inside. So 363 is going to be divisible by 11. So it's the two outside digits equal the inside digit. That's our one to remember for the 11s. So read all the rest of those, and then I want to have a go at this particular task. Okay, I want to pause the video and find out, are these numbers multiples of 5, are they multiples of 3, or are they multiples of 7? So pause the video, quickly find out, and once we've done this, you're going to get on with your task. Okay, so multiples of 5, obviously you're just looking for the ones that end in a 5 or a 0, so this one and this one, 15 and 2,505 are both multiples of 5. Are they multiples of 3? Well, if you can just keep it as is if you know your 3's really well, all the way up to 2,505. Or if you add together the digits and they're a multiple of 3, then it's correct. So we've got 32, well 32 is not. 28, 2 and 8 makes 10, that's not a multiple of 3. 15, hopefully you know your 3 times table well enough to know that 15 is in the 3 times table. And then we've got 1,268. So we've got 1 add 2, which is 3, add 6, which is 9, 9 add 8 is 17. So that means that number is not a multiple of 3. And then we've got 2,505. 2 plus 5 is 7, plus 5 is 12. 12 is in the 3 times table, so 2,505 is also a multiple of 3. We could say that 2,505 is a common multiple of 3 and 5. The last one, the multiples of 7. So remember, we take the last digit, we double it, and we take it away. Obviously, for the first 3, we don't really need to do that. We know our 7 times table by now. So 32 is not on the 7 times table, 28 is, 15 isn't. But for the last one, we take our digit 126. We're going to double that 8 to take away 16. Hopefully you remember this from the last few seconds. And if we take that away, we get 110, and 110, is that in the 7 times table? It is not. So 1,268 is not in the 7 times table. Then we can do the next one. We've got 250, take away 10. Hopefully you remember you double the last digit and keep the other ones the same. Take them away from one another and you get 240. Is 240 in the 7 times table? Well, it is not. So 2,505 is also not in the 7 times table. Okay, hopefully that makes sense, guys. What I'd like you to do now is to get on with the task. There is an extension, which is a bit harder. And for that, what you're going to need to do is to be able to do some algebra with multiples. Okay, so give it a go. And if you need any help, come to me at the drop-in. Good luck.